What is going on, everybody? Welcome to the 17th Pygame tutorial from Harrison at pythonprogramming.net for Bucky in the New Boston. Where we left off, we've got our snake running around. He's running over the apple, but he's not actually eating the apple or anything at all. So we want to start building some sort of event handling for this. And there's a few ways that we can handle the crossing over of boundaries, so to speak. So if you recall, I mean, we've definitely got boundary handling for when our snake goes off of the screen, but we don't have any boundary handling for, say, when the snake is crossing over the boundaries of the apple. So we definitely want to do that. And in our case, the apple just so happens to be the exact same size as our snake, right? So the thickness. Now, obviously, as time goes on, you might want to develop a game where that's not the case. So first, I'm going to show you guys how we're going to do it with this specific game. But then I'm going to show you guys how to do just any boundary crossover, just so you can have an idea of how it should be done. Because we're going to get away with doing it really easy here just because the stars have aligned and we're able to do it in this game. But generally, when you've got boundary crossover, your objects aren't identical in size. So first of all, our first problem here is, so I guess first, what am I speaking about anyway? So when I want you guys to be on the same page. What we're going to do is we're going to ask when the snake is crossed over the apple. But as you can see, as I'm going back and forth here, the apple's location is not identical with the snake at any given time. The apple's maybe 1 or 2 pixels down. We obviously have some crossover here, but they're not perfectly overlapping each other. So there's a few things that we can do. First of all, we can just say, well, whatever. We can just account for any time there's crossover, which is totally possible. Or we can align everything perfectly so that problem doesn't occur. So what I'd like to do is align everything, because there's, when you're making games, you want to make things as simple as possible for processing. So we have the ability to align things. Since the apple is indeed the exact same size as the snake, we have the ability to make this happen, so why not? Like, there's no reason to make it shifted down a little bit or up or whatever the apple might be. So the way that we're going to do this is, first of all, how might we do it? Well, you could set up, a grid system and make sure the apple is always within the grid. I mean, you could do some really complex stuff. But actually, what is happening here is the location of the snake is the display width divided by 2 and the display height divided by 2. Right now, and pretty much always, the display width and height are always, I guess not always, but pretty much always going to be a factor of 10, right? So it's going to be divisible by 10, and it just so happens that our snake is 10 tall. Therefore, it only makes sense that our snake will always be in a multiple of 10 somewhere. So we need to do the same thing with our apple, but the problem with our apple is it's just a random number in between those two things, whereas our lead x and y is display width and height divided by 2. So it's always going to be in the 10s, or I suppose you might get unlucky and it might be in a 5 or something like that. But you can handle this like I'm about to show you how we're going to handle our apple. But anyway, enough on that. Let me show you guys how we can force our apple to always be in a multiple of 10. So where we're defining our apple, this is already what defines the number of our apple. Now, the best thing I think to show you guys would be maybe even like a separate function. I can bring up, let me just bring up a Python idle real quick just to show you guys. You can follow along if you want, or just watch, because we are going to code this in a moment. But I just want to show you guys what we're using in a cleaner environment before we start using it. But so when you have, let's say you've got a number, so we're going to say x equals 7, okay? How might we round 7 or x to the nearest 10? Well, what we would do is we would say round, let me think here, round x, and then divided by 10.0, and then times 10.0. Hold on, let's see, round x. Oh, duh. There. Okay, and this is how we would always round x. So again, we could say x equals 17 now, and then we could do the same function again, and now we get 20, right? That rounds it up, and then we could say x equals 14. And then run that function again, and now we see that it was rounded down to 10. So that's how we can always round it to 10. So we're just dividing it by 10, rounding it to the nearest whole number, and then multiplying it by 10 again to get it out of that rounding. And so like, that's just one of the easiest ways to do it. So with that in mind, that's what we're going to do here, but it's going to be kind of, I wanted to bring it up here because it's going to look really confusing being wrapped around what's already here, because this already returns just a single number. So this might return a 17, which is then being tossed into this further equation. So I didn't want it to look more confusing than it is. It's not that crazy. So rand apple x, we're just going to do the exact same thing, right? So we put round here, so we round all of that, and then we're rounding, make sure I do this right myself. so we're trying to round this number, so round and rand range, and then we're going to divide this by 10.0, right, and that's the rounding, and then we can multiply this by 10.0, and then do the exact same thing here. We need to round it, round, and divide it by 10.0, close that off, and then times 10.0. Okay. And that should give our apple the location of a multiple of 10 every time, but let's make sure. Just trying to wrap around it real quick. Let's see. Okay, yeah, so clearly it's definitely in an X location. Let's just try one more. Or the same location as our snake head, basically. And it is again. So that's how we can get it to start in the same location. And then what we can do from there is we want to have some sort of handling as far as when there is actual like crossover between the two. So basically all we have to do for that is we're going to come down where our logic is like basically right here. And we're just going to put it right here. So as soon as the variables have changed, what we're going to do is actually maybe before, let's see, I'm trying to think if we want to do it before we draw it. We might want to call all this after we've actually drawn what's occurred. That way the user sees proof that they crashed into either of them. Because later on we'll do the same thing as far as did you crash into yourself or did you do whatever. So I guess it doesn't like super matter which way you do it, but we'll put it here for now. So we're going to say if lead underscore x equals rand apple x and lead y equals rand apple y, let's just for now, so we'll run a function eventually, but for now we'll just say nom nom. Okay, so we ate the apple in theory. So what are we asking here? We're asking if the location of x is the same as the location of the apple's x, and if y is the same of the snake's head, basically, is the same location as the apple's y. So let's go ahead and run that, make sure that that's true, and we should see some nom noms over here if that is the case. Let me just move it like right here. Okay, so there's our apple, and nom nom. Lots of apple. Anyway, so okay, so we definitely have our crossover working there. Now we're ready to maybe build a function about actually regenerating an apple and making the snake longer and all that fun stuff. So stay tuned for that. Thank you for watching.